Okay, here is your hint for number 1. So we got this suitcase falling, causing this thing to rotate. And so we're going to set up the work kinetic energy theorem here. And because we have multiple masses, we have to ask our question about each of those masses. So for instance, is anyone pushing on these external forces? No. Is there any friction slowing things down? No. Kinetic energy. Is the suitcase moving after it's fallen a little ways? Yes, the suitcase is moving. Is the object up here moving? Does it have kinetic energy? Yes, it's rotating. So both of them have kinetic energy at the end. Now, gravitational potential energy, yes, this has gravitational potential energy at the start, but it also has it at the end, so there's no change in it. So those two cancel out for the wheel. The suitcase, on the other hand, starts at one height, ends at another height. So its ending height we'll call 0. So its final potential energy would be 0, so it does have some at the start. So now we know that we have both having kinetic energy at the end and only the suitcase having potential at the start. So we look at our wheel. Is our wheel rotating, or is it moving, or is it doing both? It's only rotating, so I only need 1/2 I omega squared. The suitcase, is it moving, rotating, or both? The both would qualify for something that's rolling. The suitcase is just moving linearly, so I use the linear kinetic energy equation there. And I do need to link these two velocities, the omega and the speed of that suitcase as it falls, and that's what's the link for multiple masses. So I think about this point right here. The linear speed at that point of the string is the same as the linear speed of all of the string and thus the suitcase. So I need to use my relationship that V is equal to omega times R, where R is the radius at which I'm looking at, or the connecting radius for that string that's connecting them in this case. And you're going to go ahead and substitute V squared over R squared in for omega squared and solve for I. There you go.